All right, I got 6 o'clock. We're gonna get rolling here because I don't think I'm gonna be here all the whole hour because this is to me it's a pretty self-explanatory week. So I'm going to share my screen and minimize the faces because there are no faces. And then so are there anybody have any questions right now? Any glare? Oh, hold on. You any glaring questions that you need answered?
Not for me. It all looked pretty straightforward last week.
Yes. It was just the box plot. It worked for some people, and some people it didn't work for me. I couldn't figure out what the problem was, but as long as you guys put in the screenshot, you got the last step. That's it. It's just sometimes a glitch. It happens. Honestly, in terms of that, like I mentioned, the biggest to somebody, the scatter plot and the history. Well, the histogram is really important, but for this class, really the only graph you're going to be using is the scatter plot. So if you can work through the scatter plot and pull up the scatter plot, you're going to be just fine. And it's really straightforward and simple and that. So, in terms of where we're going with this, all the stuff I'm giving you now, 98% of it you'll be using in the second half of the class. So last semester, the class was set up, it was a good, but there was a lot of fluffy little things in it that took away from the moment when we got to like week 11 or 12. It took 11 weeks to get to really testing. And then it was hard to understand the material that was out there because some of it you talked about in week 1. That's why we're continually going back to certain things and kind of connecting the dots. All the dots will not connect. And if you try to make all the dots connect, you're going to struggle. Get what you get, ask the questions on what you don't understand, because then you'll have enough information, like I always say, to be dangerous enough to walk into your DNP. And when you start to pull data and she says, you need to run a 1-sample t-test, or you need to run a paired sample t-test, you're going to forget everything you've learned until you go back and look at it, and you'll be able to understand and be able to, if you keep your notes from here and you keep everything and you set it aside and you're ready to go, when somebody else is struggling to learn it, you're going to understand it and you're going to be able to go, oh, it's this, and bam, I'm done. And you'll be able to draw conclusions from this. So part of what I want to start with after I go through the next 2 slides is the idea of we've done conclusions, but now we've got to expand that just a little bit. And I don't have a slide on this. It's just something I'm going to talk about because I'm going to talk about it again. So the first thing I want to say is thank you. A lot of you are starting to read the announcements. You're starting to read your emails. You're seeing, well, when there's a disaster or something happens and it doesn't work, you're going to the announcements and looking and finding information. That's it. If it's not, like I said, if it's not in Canvas at this moment in the module, it'll always come out in an announcement. Now, if you get there and it's not there, now that's when you go ahead and reach out. Some of you have texted, some of you have called me. I've had to call some of you, and then some of you have done that. The email is there, and all of those are perfect. Don't worry about it. You're not bothering me, okay? The biggest thing is I'm very busy on Sunday with 2 church services, actually 3 church services, 2 in the morning, 1 in the afternoon, and then I go to my night job at 6. So if you got a poor grade on Sunday because you turned it on Sunday, talk to the other people in the class. They're going to tell you that if you just do a little bit on Monday, Tuesday, and Wednesday and your lunch hour, you should be able to get a lot of it done. And then you've got your discussion board due on Wednesday. I think it's Wednesday night. And you get that done. You do that. And then Sunday is relegated to next week, and you're getting prepared for next week. And then you do a little bit Monday, Tuesday. it's done. You can turn it in and get your feedback. And if you waited till Friday to take a little time to do your feedback and get it back, I would check the next day, because you're always generally going to get it the next day. Check and see how much you have to do and get it done. If you're done by Wednesday, guess what? Now the rest of the week is gravy. So I'm just laying it out because I understand you're busy and I understand you work lots of hours, but I'm one of those people that's in the same boat. Not even now, but even then, when I was in my dissertation, I worked 80-hour weeks. I drove from Long Beach to San Diego to teach 2 nights a week, leaving at 2:30, getting home at 11, and I still got my work done because I managed my time. I worked on my lunch hour. I worked every moment I could, and I got things done and I got it off my plate. If you get it off the plate, your stress level is going to go down, because some of you are just making simple mistakes that don't get edited really on if you just do your work on Sundays. And like I said, you're in the dissertation process. If you're sleeping, you have time to do the work. Sorry. It's hazing, guys. I'm not going to lie to you. This is hazing. You are moving into a place where when you finish this, you are in 1% of everybody that starts their dissertation finishes. If you are handed that paper with a doctorate on, you're a part of 1% of the United States that ends up being called a doctor in any way, shape, or form. More people drop out than actually finish. So know that none of this is hard. It's going to be challenging. It's going to push you. It's going to stretch you. And when you're done, the satisfaction is beyond any measure that you could come to. Watching your child being born, watching your child being graduated, but this is for you. In the end, it is for you, and only you win at that one moment when they say, congratulations, you're a doctor. And guess what? Once they give it to you, they can't take it away. I had a lady at work who was halfway through a dissertation and just walked away from it and could have finished, made tons more money, but said, I'm done, walked away. So my thing is, thank you. Keep working hard. It's going to pay off big dividends, especially in the second half. The announcements, again, staying with the same idea. We are moving toward the midterm, and the midterm is generated by the notes. Okay? You do the notes, you understand the notes, you have the notes ready, you can use them on the test. It's a one-shot deal, but this is the only one of this and the final are one-shot deal, but you have your notes, follow your notes. Everything came from the notes, so should be just fine. Preparation is the key. Reading them over, making sure you understand them. A lot of the stuff that we're doing is all in there, but it's basically from the notes, because I drive this class from the notes. I hated always having people doing stuff and then coming in and the test is totally different. I can't tell you that you understand the question, which you should, but bottom line is every answer is from the notes. Okay, so we're going to move to a place where first, before we do the methodology portion of it, where we talk about conclusions. And I've continually in the last 2 weeks talked about the sliver method. Everything is a sliver. So the data that you're turning in is a sliver. It can give you like males are smarter than females. That is a conclusion. But what you're looking for when you're doing your dissertation are conclusions that stapled on each other. Okay? And that conclusion can come directly from the data, or that conclusion can come from what you know and what you've read. Okay, so it's not just locked into what that data is. You're reporting exactly what the data is, whether you're taking it from previously done data, or if you're turning around and you're building your own data. It doesn't matter. You're looking for who, what, why, where, and when. Okay, and it's really the who and the what when you get to that place. Men are smarter than women. Okay, in what? Why are women smarter than men on this test? What are the factors that go into the reasoning for the men being better than women? That's part of how when you set up your methodology, if you do it correctly, you set up for success. This right here is my specialty, setting up methodologies so they are successful and you get data that is viable. I've only had in 15 years probably 3 sets of data that basically stunk. One of them because he had 70 questions on his survey. So he never really was able to find a path. When you're doing the methodology, you're setting yourself up to prepare yourself to drive through and being able to create a path to drive through to have answers to answer at the end of your paper. The time when you don't want to do this anymore. Neighbor across the street, we got your results and the conclusion. She's a doctorate in nursing. I don't know what's yet. And she says, I'm done with this. I said, well, you got one big push left. When you get to that side, you got one big push. You find these things, you write it up, and it's there. Understand you're not making anything up. That's called lying. We don't do that. It's Christian. Okay? But the big thing is whatever your data tells you is exactly what you're doing. You're going to report, whether you like it or not, whether it's opposite of your thinking or not. It doesn't matter. But your methodology is there. So in another week, we're going to talk a lot more about IRB. So we're not here for 4 hours. But you have to do an institutional review board. Okay. And what that institutional review board, it protects humans. Okay. It protects you. It starts with protecting the school. It protects you. It protects the participants and back and forth. Because when you are using participants, you can be sued for many, many, many reasons. And IRB solves that problem and takes a lot of the liability off of you because they're going to check your methodology versus what kind of a survey you're running or what kind of data you're looking at. And some of you in here may not have to do an IRB, but I think most of you have to. You're going to turn in a lot of what we have been talking about, such as your research question, your purpose statement. And all of those things have to line up. Okay? You can't go out and say, I'm going to inject water into 50 people and see if they become more hydrated. First off, you're not going to be able to inject anybody. I go back to that one where the nutritionist wanted to do brainwaves. Like, no, it's not going to happen. I won't pass IRB. You do not have the qualifications. Everything that you're doing, you'll be set up for success. It's within your qualifications. Why? Because you don't have time to play games. My dissertation, I had 3 different topics that equaled out to 60-page papers each time before I even got approved because it became a hot topic. First one, they didn't want us to use students, high school students. Boom, even though I was teaching research methods, still wouldn't do it. Coaches, right then the coaches in the Midwest, it probably became a hot topic because they were getting fired because they were praying over, private schools were praying over the speakers. Okay. And then the last one was my mentor called and says, I turned in, he says, it's a hot topic. You're going to go to, you're going to do the pregame ritual, and basically everything fell into place. And it was really God setting me up for success. But at that moment, I didn't see that right away. But then at the end, I went, oh, all I could do is praise Jesus because, man, without that happening, both of those other 2 would have been a huge challenge. But I got to keep all my literature review, which is the biggest part. Okay, there's another story on that, but I'm not going there. So methodology is like a legal document that you're going in your paper. You are going to be very specific on a lot of areas that I'm not going into all those areas because it's a lot. But think of it this way: it's your legal document. You're going to be very specific. If you are going to hand out a survey, you're going to say, I'm going to hand out the survey. I am going to be present when I hand out the survey. I am going to be available for questions. I'm going to do this. You have to tell how you're going to get your participants, where you're going to get them from, where you're going to get the data. Do I have permission for the data? And I'll have to get paperwork for that. If you're working in a facility, the facility has to know, the facility has to do all this. And all this has to go to IRB, and then they make a decision. Most people pass. It's when you leave things out or you're vague. You cannot be vague. It's got to be straight to the point. Okay. I'm doing a case study on one particular. You guys don't do it, but I'm doing a case study on one person. You have to have an informed consent from them. You'd have to have paperwork from the place. You might have to have you might have to have an informed consent from somebody outside, such as the guardian or the caregiver, or whoever's in charge, has legal custody of that person. Yeah. You'd have to get all the doctor, anybody's going to be working with you to do an informed consent form. They have to know what they're doing. Okay. So setting up your methodology is important. Now, the minor portion of that is you're setting up the methodology to be successful, to get good data, or at least some good data. Okay. And when you do that, then all of a sudden you become dynamic and your paper will flow well. I've had tons of people that have just kind of glossed over there, and we fought back and forth. And at a certain point, I just let them go. And then when it comes out bad, I go, I told you those questions weren't going to work. Can't make you do something. I can tell you that question doesn't go anywhere, or that data is not good. So let's go to my next slide. In respect to everything that you're doing, there are many people, especially in my field of psychology and your field of nursing, that want to know everything. We don't get to know everything. Again, we're back to the sliver. Okay, you're going to be picking something narrow enough that you can finish it in the time frame that you can do, but it's going to have we'll talk about research gap in another class, but it's going to have enough. It's going to have enough meat and bones. Always think of it this way. Everything goes from simple to dynamic. You start simple, what you create turns dynamic. I know two of my mentors, my reader and my methodologist, did not like my topic. They thought it was cheesy and everything else. They didn't know me like my mentor knew me, and we had never met before. And he understood where I was coming from better than the other two. And he said, we're going with this. And then when I was done, they both said, oh my gosh, this is amazing. It is so in depth and it's so on point. I figured it was just going to be a flood paper, but it turned out great. It was simple. It was a simple topic that didn't fall into a lot of what they actually done there. A lot of them had done on veterans and stuff like this. Mine was on athletics, where my specialty was. So understand that. So now when you're talking about what you're going to be doing, we're talking about statistics, it's the same idea. You got to know what you're doing to go in the direction that you're going, and you won't understand everything. Please don't stress. Listen, gain it, ask questions, and know that sooner or later you may have to use it, you may not. Statistics is huge. There's tons of stuff I can't get into. There's also a whole other side from this, which is advanced statistics, which you won't use, but in the projects here. But if you were doing a MANOVA and you were doing a multiple regression and you were doing this and you're doing that, it's much more elaborate. You're dealing with inferential statistics. There's inferential statistics and descriptive statistics. Now, what you see in front of you, you're right here, you're dealing with inferential statistics. There's parametric and non-parametric. And I'm going to show the example in a little bit. Okay. Again, those assumptions that you worked on last week fall into parametric. If it doesn't follow the rules, such as you see down here, it says parametric tests are powerful, but need to have strict assumptions. Non-parametric tests are flexible and robust, especially for messy and small data sets. So if you had 30 or 40 people and it turned out that your data wasn't, we're going to talk about that in a little while, the true normal distribution, as we started last week, and we showed did the data curve, the bell curve, and it was skewed left or skewed right. Now you go into the parametric test. By the way, they look the same, and I'm going to show you in a little bit. So examples of parametric tests, which you're going to be doing the two tests. I think the ANOVA, you're going to be doing the correlation. Non-parametric tests, the Whitney-Mann, the Kurzweil-Walls test, and the spearmint rank correlation. Think of it this way. A lot of those do the same exact thing. except they have a different name. And all that different name is guess what? The assumptions were not met. Well, guess what? The assumptions aren't met. It doesn't mean it's bad. It means that it wasn't met. And you state that clearly. Everything you do, you state clearly. Okay. You may even show that it's not that, and you say the data was skewed to the left, and we use the Spearman rank correlation. Okay, it's that you know, and the rest is key differences here. Okay, and then again, same thing. It's the same thing as the two conclusions are the same, but just understand that it's the same. It's the same test, but the assumptions have not been met. And all you're doing when you do that is you're telling the reader of it that the data was good, but the data was skewed. And that way you're not, we throw away a lot of data because nothing is true, very rarely, like my professor said, you got a better chance of winning a lottery than having perfect normal distribution. Okay? So let me escape this. I'll back to it in a minute. I'm going to bring up SPSS real quick. Now I have a set of data here. Okay. So one of the things that would have made your life easier is if I would have ran this for you, but and showed you this. So as you can see at the top, you'll see the word analyze. You guys have been, so you guys have done this. And then you go to descriptive statistics, and then you go to explore. This is kind of like a big snapshot of everything. Okay. Don't know where the box went, but let's try that again. Analyze, descriptive statistics, explore. Missing the box. There is something. Of course, you don't want to work. Okay, so this is the Explorer for, let's see, years with current employers. Oh, I might be frozen. Are you guys still there?
Yes.
Yes.
Okay, we're not completely frozen. Well, I'm going to come back to that because I don't want to stall us out while this massive program starts. So your Explore category allows you to see a whole bunch of stuff and do everything. Send it. Demo, say, open, hurry up, hurry up, hurry up, hurry up. Okay, so if I go to analyze and I go to descriptive statistics and I go to explore, and let's say I'm going to say household income. It's going to give me a few things just in general, maybe. It might or it might not. There it is. So basically, if I just do it like this, I'm going to find the box plot. It's going to give it to me automatically. Okay. So I'm going to do it one more time. Analyze, descriptive statistics, and then I'm going to go down to explore. And then when the box comes up, I'm going to hit statistics. And I'm going to ask for my outliers, and it'll give me my outliers. And then it'll ask me for my plots. And I'm going to save the stem and leaf because you already know that one. Histogram, normality. And then I'm going to hit continue and hit OK. So here it's going to give me everything. There's my skewness, my kurtosis. I think I showed you guys this last week. Extreme values. It will tell me where my extreme values really are. There's your test for normality. Okay. But then here you can see that it's skewed to the left. Or I'm sorry, skewed to the right. Okay. So we wouldn't be able to run that test as it is. You can see but then you go down and look at the box plot. And we didn't have this last week, but I found it this week, that these are all outliers. So the data is not the greatest, but it's still usable if this is something you're going to do. So basically, I'm going to run a test that is not in this compare means, like one sample t-test, independent sample, okay? So now I'm going to go down here and I'm going to find non-parametric tests. And it's so cool that they give you one sample, okay? And then I hit this button. What it just did. Analyze, non-parametric, one sample. I'm sorry, I don't know what that new box is. Oh, there's a box. Okay, so now I think it was how not. If we make this box a little bit bigger, I income, I drop income in there, and then I hit OK. And it's going to give me it's going to give me the same thing. No idea what all this is. Should give me the same. So if I actually ran a one sample t-test, I'll show you this again another night. That's the change. So in this one, if I'm running a one sample t-test, and I grab that word income again, and I slide it to the box. Now, the test value on this, let's say I want to pick a test value of 50. Okay, and I hit OK. So we would turn this into thousands, and in the mean here is 69,000. Okay. If I can figure out where the box is, this is the way it would look. And it's got all this stuff. And by the time you're done, you'll understand what all it is. But then again, tonight we're going to talk about mean, and we're really going to talk about standard deviation. Next week, we're going to talk more about the significance level and hypotheses and how that works. So you're not going to use all the boxes, but there are certain boxes that if you find it, your homework goes faster. Okay. So let me get back to the meat potatoes, this bad boy here. Let's see. Okay, so is that from here? And now if I'm looking at this, there's three different types of collection methods: quantitative, qualitative, and mixed. You could be doing any of these. A lot of you will be doing quantitative, which is basically numbers, which is statistics, which you're going to learn in this class. Some of you might be doing observations with us on the qualitative side. Qualitative goes down to words. It really comes down to a few things. I'm in the next couple slides. If I'm doing mixed, now I'm doing both. I may do a survey and I may be doing observations, or I could be doing focus groups, or I could be doing interviews. Those are the things that you need to know. Okay? Because it's real important. Somebody says, well, I think that's qualitative. You should have, by the time we're done, you should have an idea what qualitative is. You're going to be doing interviews, observations, focus groups, short answers. It's like you're doing the evaluation from here. You have a Likert scale, which is like 1 through 5, strongly disagree to strongly agree, or he's really bad or he's really good. Okay, cross that timeline. 1, 2, 3, 4, 5. 3, you generally in the 5 will be neutral, which is your base mean number. Okay, and you pick one of those, and those added together give you something that you can run with. Okay, if I go down and he says, well, how was Dr. Jeff good? And you write that out. Now you're doing qualitative, because we're looking at an experience there. What was your experience with Dr. Jeff that was good? At the top, I'm looking for a perception of whether you think I knew the material or didn't know the material. Okay. All right. So that's that one. Here comes the next one. We're going to look at it again. Now, there, as you can see, it's a crossover. Again, the same thing I just talked about, but you can, as you go, you can stop it and read it. It tells you what kind of data collection you have. The more that you know about this, again, you're dangerous when you get to the other side. Here are some ideas. Quantitative, he is 6'7" tall. Qualitative, he is tall. Okay. He eats 6 meals a day. I don't wish I ate 6 meals a day. They eat all the time. There's differences. You're looking at an experience. Well, did they eat a lot of food? Yeah, they ate all the time. Okay. She's good with money. She saved 2,000. Much more definitive on the quantitative side. Qualitative side, you're taking what they're saying and you're reading it and you're looking for really big keywords in that one. Over here, you're getting answers. So the question would probably be for the $2,000 savings. It would be, how much money did your wife save this month? Or how much money did your husband save out of his check this month? He or she saved $2,000 every month. Okay. So let's get into the mean. Now, I'm not going to spend a lot of time here because we've been kind of beating this up a little bit, but this is the point where we're getting closer to that other side. And I need you to understand, we're always looking at a difference when it's the mean. Okay. So anytime that you're looking at a test that is like we're keying on the mean. Okay. One sample t-test, independent sample t-test, ANOVA. Okay. Those are 3 examples of how there's more, but those are 3 examples of testing where you're going to be looking at the mean. And it goes 1, 2, 3 or more. One sample t-test is against 1. Now, I just ran one and I put 15 in there or put a number in there. So you're going to run that against a test value. It's either going to be above or below. Okay, when you go to the independent, now that's 2, male and female. Kind of like what you looked at when we did the males are better than females. Okay, but we're looking at the difference in the means. Okay, and when you go to ANOVA, now it's just a tad different. You're looking not only at the means itself, but you're also looking at the group means. So like 3, like upper, middle, and lower class. If I've got a 500 people in my study, and I look at that, I can run it against certain things and find out and draw conclusions on, well, most everybody's rich. I can give you an example. I worked for this I did stats for this company that was having police officers and community get together. They'd have meetings all day, and then they'd have a basketball game at the end called Game Changer. Okay. I looked across the board at all different factors, but they asked the question of what's your household income? Now, the people that were coming to these things had a household income. Let's say I'm just going to throw out a number of, let's say, $50,000, which means the mean is there. The numbers can be broadened. The other part of that, and we talk about getting a grand conclusion. Most of those people lived in the community they said they were that was around the place of the meeting. Okay, but the police officers that were being involved in this from that area. So let's throw out like something like East County. You did it in East County. You have police officers from whatever area in East County of San Diego, and you have people from East County, San Diego is your other set of participants. Those officers did not live in the neighborhoods they policed. Their meat, and I don't remember the number, it was years ago. But let's say they're making $150,000, $200,000, and your people that your mean over on the other side was let's say $50,000. They're not living there. They're living in Torrey Pines. They're living wherever else they want to live. They're not living, let's say, in a neighborhood like that, because they are making the money with the overtime and everything else that they do. They're making that kind of money. So it was easy to help them build better classes to bring them closer together, figuring that these people are really not living in the neighborhood. and they're making 10 times as much money, which can change the bias toward the people living in that neighborhood on top of everything else that goes on. I hope that kind of is an analogy that kind of helps you along a little bit. So we're looking at difference in mean. Okay. Yeah, I'm not gonna really go over this, but if I made you take a whole bunch of data, I'd have you add up all the numbers, divide it by 1, 2, 3, 4, 5, 6, and it's going to give you the mean. We report the mean to the hundredths place, 10, period, decimal point, 1 space, 2 spaces. Okay. Standard deviation is simple. At the same time, it's not something, if you don't know it, it's gonna take you a little while. And bottom line is that really, if you understand the number at its basic core, you know more than a lot of people who do statistics. Okay. And my first professor was horrible. My second one was okay. My third one just gave me the bare minimum, which is, man, it's just the spread in that bell curve. So I'm giving you an idea of a standard deviation. We're looking at the variability. So if you look on this side where it says standard deviation, okay, shows data variability. Okay, basically it shows you where the data is and how variable it is compared to the bell curve you see on the right-hand side. High data points. So I mean, go back to what we learned last week. Lepto, meso, and platycurrent. Okay. A lepto would fall into the low standard deviation. So the number you get, if it's really low, okay, it's super low, guess what happens? Now you know that they are closer to the mean. It's going to be more between meso and leptocurtic. Now, if you go back to the high and they're more spread out, now it could be meso to platycurrent, meaning they're flattened out and it's really, really spread out. Okay. Now, if you look across here, and I'm going to see the next one, but you'll see down here -1 and +1. So if you have a negative standard deviation, that's a little circle with little curly Q on the end. That's basically -1 away from the mean. You're going away from the mean. The way I always tell it is, I put a board at the other end of the room, and I put a string down the middle. I took a tomato, and I threw that tomato as hard as I could, and it splattered out. The mean, if I hit that line right in the middle, how far it splattered out would tell me how far away from the mean of the middle of that tomato hitting that line perfectly it spread out. And I could tell how wide it was by basically, like, let's say I'm doing inches. I'm going out this far on this side, and let's say it was equal, and it went out 5 inches on this side and 5 inches on this side. -5, +5. That's basically a generic mental picture. Standard error of the mean shows accurately the sample mean estimates of the population. Okay. And I'm not going to stress on that too much because we don't really do that. Again, high standard deviation, low standard deviation. I found this picture is pretty cool. Kind of like lets you know how it is. Now we take that and we put that into the normal distribution. Okay. Now, when you're looking at the normal distribution, we see the bell curve. Okay. Normal distribution is one of the most important concepts in statistics. It shows how the data is spread out around the mean. It also tells us what kind of test, parametric or non-parametric. Now, you see the center line here where it says mean, okay? That is where the middle of the data is, regardless of where it is, okay? Being that's a perfect bell curve. 34% here, 2.1, and you'll see that the means fall away from the mean. They go up away from the mean. 68% fall in that first one, and then the 95% in 2, and 99.7 amount of the data. Okay. Basically, you do the histogram and you look at the histogram. If it looked just like the bell curve and it fell within there, you would say it was there. If it was just a little bit off, you'd say relatively normal. Okay. Most of the data falls close to the mean, and very few values lie at the extremes. If they lie at the extremes, such as left or right skew, Now you're changing your test, but everything is all, I always say, everything's all good. You just got to know what it is, what it looks like, kind of what it is, and be able to do this. One of the reasons why I don't do like the formulas, I don't do the formulas because back in my day, we had to memorize a lot of the formulas. And I'm like, why do I need to memorize it if I'm not going to use it all the time? And I can just look at it and then fill it out and be done. And I never understood that. And then we went to the computer and I said, no, I don't need it. I just plug my good data in, good data out. Now I can analyze and make sense of what it is and not just try to get to the final conclusion. Okay. And that is really the end of my my big presentation for tonight, because that kind of covers pretty much everything. Understanding that is in the idea of, for these 2 weeks, the biggest portion of this, if for us, is really the mean. If you understand that there's a difference in the mean and you can understand the definition of the test that you're running. So kind of like, and this is what I was told in my 2 weeks of learning SPSS statistics. You're choosing a test that runs the data in the proper manner, and you will end up getting information that you can use. So give you an idea of the one sample t-test. I'm at Starbucks right now, and I can see across the room that screen. And next time you go to Starbucks, look, you can see the screen, and it says how long that Mary, when Mary drives through, she hits that first box, and it starts a timer. And then that timer stops when she pulls up to the window, and a new timer starts. So how long did it take her to get from that window to the window there? Then there is a third one that goes from when she does her order to the time that she leaves. And that gives them a number for Mary. John comes through, it's another set of numbers, and Mike comes through, and so on and so forth. Then how many, I mean, you got to imagine that there's hundreds of people that come through a Starbucks drive-thru. You compile all those numbers, that ones, let's say just that one single number from ordering to driving off that other, driving away from the window. That's why when sometimes you go to fast food, they ask you to pull around in front. It's not because they're being nice. You're not on the box anymore, and it closes out the window, and they look like they're faster than they really are. So that skews the data. But if I'm at Starbucks and they go from there to there, and let's say I'm picking a number, it should take 3 minutes and 14 seconds. That's called a test value. So I take the 1,000 people that came through the line. We don't care what they ordered, how much they ordered, anything. All we care about is from point A to leaving point B. And I take all those numbers and I put them into SPSS. And now I go in there and I click and I run a one sample t-test. And I say that time should be 3 minutes and 14 seconds. And then it pumps out a mean. If that mean is above 3.14, we're going too slow. Now, if it's below, we're doing really well. If it's really below, let's say you're getting them out, everybody out in 2 minutes. Okay. All those kind of tests and these number tests like t-tests are set up for you to figure out which direction it's going. So if, let's say my number, I'm telling as the big dog at Starbucks, I'm saying you guys should have these people out in 3 minutes and 14 seconds, and you're pumping out in 4. First off is why? What procedure do we need to change? And this falls into your DNP. Most of you are going to be looking at something to see if it works. And why does it work? Or what works? Again, we use those words. What works and what doesn't work. Okay? And looking at the data, we can then point to a conclusion of maybe we need to do this instead. But the one sample t-test will tell you that if it's something that can be run that way. If you're looking at something in patients and you're looking at male and females, why are males leaving the hospital before the females? We like males better than females. The doctors like males better than females. We can break it down even that. Let's take knee injuries. It's always an easy one. Let's say reconstruction surgery on a knee. Why are the women taking longer to get out than the men? What part of the process? That data right there won't tell you that. That is other data that you would pull, such as a descriptive or another inferential statistic that you would run. So it can be test on top of tests. It could be a question on top of a question. Okay. How long was their surgery compared to how long they stayed in that hospital? Okay. Before they left. A lot of times they go home in a couple of days, but how long is a rehab taking to get them out of the hospital? What processes need to be changed? Okay. Stop sharing. All right. So thank you to the 11 people that are here. I'm going to make one last caveat statement here. So can somebody pop in and tell me, was it easier to watch the video the way I posted it last week? This week, I should say. Or last week, I mean.
I like the video. It was helpful for me.
Yeah, so I won't be able to get to that till tomorrow morning. I don't know how it works for you, but this is a cloud-based gig. So it may be available if you go into Zoom and go to previous meetings. It might have the recording there if you want to get to it tonight. But I will take it, drop it in my Camtasia, and I want to take out the dead zone at the beginning. That's what I did last time, because I think the dead zone was like almost 7-8 minutes. And that just saves a lot of space and time. And then I'll put it in there, and I should have it up probably about 10 o'clock tomorrow after class, unless I can get to it before. It depends on how long it takes me to get to San Diego tomorrow. And then I'll try and get it up first thing in the morning. If I get home tonight and it's up and it's ready, because sometimes it doesn't pop up, okay? Know that every time that you go in the room and try to go into the room, it starts the recording. So if you go to an old one and go into the room like we are now, it sends me a recording of your face or whatever, your face or whatever you're staring at the screen like, why is it not working? So it's some of those things are pretty funny. So as soon as I have it, and if it doesn't happen tonight, it'll be there in the morning. I will put it in there. I'll export it, get it, post it into in the studio, and get it in there. Okay. I don't know if you guys can get it out of the studio too, but I'll do it. I'll do the email and the announcement, and you should be able to get it. And again, I forgot this one last thing. Some of you are gung-ho, and I love you to death. Okay. But I really need you. I don't know if it's available yet. I think it should be, to not start on the week 9 till later, please. It can cause you a lot of work. We need to be able to understand how you do everything before you jump in there. So there'll be video. I'll be sending stuff out weekly on that, like on Saturday, to give you a head start. But if you're jumping like a week ahead, it's not that. Know that there are 2 assignments. They're both due by Sunday. They have the same editing, but you don't want to do both assignments at the same time. Unless you're waiting till the weekend and then you're on your own. You really want to do the first one and get it approved by me, because then the second one goes really fast. It's the same exact test, different set of data. The first one, you'll see it. The boxes and all the answers are in the book. All you have to do is write it up. There's no SPSS boxes anywhere. That's all for you. You fill in the blanks. But if you rush and do both and you made the mistake, now you just got to say, hey, you need to go back and do the other one. If you get it done on Monday, you have Tuesday for the meeting. You might have your edits done by Tuesday. You can then do the other one in about, it doesn't take long. Once you understand it, it just doesn't take long. So being prepared, or if you get it done on Sunday, if you've done it like I said earlier, You know, I'm done on Sunday. You turn around on Monday. You turn it in. I'm going to get it back to you on Tuesday before the class. You're going to know most everything. You just have to get the other nuances. And everything gears toward the final. So you're going to get a one sample. You're going to get the descriptives, and you're going to do the write up for descriptives. It's going to say, write up a descriptive sentence for that. It's going to be just like you did in class. So if you keep all your stuff, you do all your notes, everything else, you're going to have a few questions along the way, but you're not going to be using SPSS to get the data. You're going to be given a picture of data. You're going to write it up, because if you do that, you can do anything. All right. So with that being said, I'm going to stop the recording so we get started.